we now discuss the solution of a problem from the section Sets, Relations and Functions. The problem is on the types of relations of a set capital A. This question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the Shift 2. The problem is, let n be the set of natural numbers and a relation capital R on n be defined by R is equal to the set of all ordered pairs x comma y belongs to n cross n, where x and y satisfy x cube minus 3x square y minus xy square plus 3y cube is equal to 0. Then the relation R is, we are given 4 options. Option 1, reflexive but neither symmetric nor transitive. Option 2, an equivalence relation. Option 3, reflexive and symmetric but not transitive. Option 4, symmetric but neither reflexive nor transitive. So we are given capital N is the set of natural numbers and R is a relation defined on N like this. And then we have to identify R whether it is reflexive, symmetric and transitive, and then go to the options. Let's get into the problem. Before getting into the problem, let us recall the following definitions. Relation. What is a relation from a set A to set B? We have two sets A and B, or two non-empty sets are there with us, and a relation R from A to B is a subset of A cross B, where cross is the Cartesian product of A and B. That is, R is a subset of A cross B, then R is a relation from A to B. If R is a subset of A cross A, that means it is a relation from A to A itself, then R is called a relation on A. And the relations on A are classified, and we have the following types of relations. 1. Let A be a non-empty set, R be a relation on A, and the first type is R is reflexive if the ordered pair x comma x belongs to R for all x belongs to A. 2. R is symmetric if y comma x belongs to R whenever x comma y belongs to R, true for all x, y belongs to A. Read this carefully. Whenever x comma y belongs to R, then y comma x must belong to R. Then it is called symmetric. And third type is R is transitive if x comma z belongs to R whenever x comma y belongs to R and y comma z belongs to R, true for all x, y, z belongs to A. So whenever x comma y and y comma z belongs to R, then x comma z should belong to R and should be true whenever this is true. That means for all those situations, whenever this is true, this must be true. That is the meaning of the for all x, y, z belongs to A. Then R is transitive. And we have the definition of an equivalence relation on A. And if R is a relation on a set A, then R is said to be an equivalence relation if it is a reflexive, symmetric and transitive. So if all the three types are true for the relation R on A, then that relation R on A is said to be an equivalence relation. Let's get into the problem now. Now, we have capital N is the set of natural numbers, and a relation R on N is defined like this. R is equal to the set of all those ordered pairs x comma y belongs to n cross n such that x cube minus 3x square y minus xy square plus 3y cube is equal to 0. So, if x and y satisfy this, then x comma y belongs to R. Now, it is straight, you can say that R is reflexive. Why? If you replace y by x, then you will get x cube minus 3x square into y. Y is x. 3x cube minus x y square. It means x square, x cube. Minus x cube plus x cube cancels. And plus 3y cube. Y is equal to x, 3x cube. 3x cube plus 3x cube minus 3x cube cancels, and it will be 0. That means all ordered pairs x comma x belongs to R. That means x comma x belongs to R for all x belongs to n. Thus, R is reflexive. So, you need not go into any further analysis. But to talk about the other types of relations on n, you have to factorize this given polynomial in two variables, polynomial equation in two variables x and y. So, that we do now. That is, x comma y belongs to R if and only if this equation is satisfied. This equation is now made a, factorization is made for this. So, that is equal to 0, implies and implied by. So, in the first two terms, you take x square common. So, x square into x minus 3y, and in the next two terms you take minus y square common into minus y square into x minus 3y. X minus 3y is a common factor, and that will the implies and implied by x minus 3y into x square minus y square. But x square minus y square you can write it as x minus y into x plus y. So, the factorization is here. That means x comma y belongs to R if and only if this is satisfied. This factorization is satisfied. So, this is the, let's call this as the equation 1. Now, from this equation, if you replace y by x, then you will get x minus y will be 0, and this is satisfied. Therefore, x comma x belongs to R for all x belongs to R. X comma x belongs to R for all x belongs to n. So, that means this is clearly is reflexive from this also. And let us see, suppose x minus 3y is equal to 0, then x is equal to 3y, then 3x is 3y comma y, that is 3y comma y, then this will be 0 because of this factor becoming 0 and this is 0. So, therefore, 3y comma y belongs to R for all y belongs to n. And lastly, if you take the third factor x plus y, so y is equal to minus x or x is equal to minus y, then you will get x comma minus x, y is equal to minus x. So, x comma y is minus x comma minus x belongs to R for all x belongs to n. So, these are the ordered pairs belongs to R, and for all x and y belonging to n as the situation may be. So, we continue in the next slide. We have, so far this is the situation, and now A, from this 1, it says x comma x belongs to R for all x belongs to n. So, that means R is reflexive. Good. Now, is it symmetric? That is what we wanted to see. Now, B, from this, put y is equal to 1. Then it will be 3 comma 1 belongs to R. Yes. Now, we want to see whether this 1 comma 3 also belongs to R, at least in this case, but it should be true. Whenever x comma y belongs to R, y comma x must belong to R, true for all x and y belongs to n, then only it is called symmetric. Now let's see for this. So 3 comma 1 belongs to R, 1 comma 3 whether it is belongs to R or not. So for x is equal to 1 and y is equal to 3, these things you take and substitute in the here. So in the factorization. So in that substitute x is equal to 1 and y is equal to 3, we will get this. But this is clearly not equal to 0. So if it is not equal to 0, because it is if and only statement, 1 comma 3 does not belong to R. So 3 comma 1 belongs to R, but 1 comma 3 does not belong to R. So the symmetry is not satisfied. Therefore, R is not symmetric. And R is reflexive, R is not symmetric. With these two, we can, we can eliminate some of the options and we can get the answer like this. So R is reflexive, R is not symmetric, and we have the options here. And because R is not symmetric, option 2, that is, it is not an equivalence relation. If it is an equivalence relation, it must have all the 3 properties: reflexive, symmetric, and transitive. Because it is not symmetric, it is not an equivalence relation. Option 3 and 4, they want symmetry on the relation R, and that is why 3 and 4 are also not true. So since R is not symmetric, options 2, 3 and 4 are not true. So the only option is option 1 must be true. So therefore option 1 is true. I know that I have not verified the transitivity, but you can eliminate like this. And as an example, I am telling you, this is not always possible. Sometimes you can do this in the examination. And therefore our answer is option 1. Agreed. And the question and the discussion of the solution of that problem is over. Option 1 is our answer. But I wanted to show you that R is not transitive in the next slide. So R is not transitive. So this is what we have. And R is reflexive, R is not symmetric. Now, see, we have 3 comma 1 belongs to R. We have already seen y is equal to 1 if you substitute, 3 comma 1 belongs to R. And from 3, if you take x is equal to 1, 1 comma minus 1 belongs to R. 1 comma minus belongs to R. So 3 comma 1 belongs to R, 1 comma minus 1 belongs to R. Is this 3 comma minus 1, is it going to be an element of R? So for that, for x is equal to 3, y is equal to minus 1, go and substitute here, whether it is equal to 0 or not, we can see. So x is equal to 3, y is equal to minus 1. If you substitute in this, you get this. It is clearly not equal to 0. Therefore, 3 comma minus 1 does not belong to R, even though 3 comma 1 belongs to R and 1 comma minus 1 belongs to R, but the 3 comma minus 1 does not belong to R. Thus, the transitivity is failed. Therefore, R is not transitive. Thus, we have the conclusion. Thus, R is reflexive, but neither symmetric nor transitive. That is the option which is true. That is the option 1. And we have already seen that. So, that is the discussion of the solution of the problem from the section sets, relations and functions. And I am sure that you have understood the solution of this problem. And the section on sets, relations and functions is very important. And questions on that, they do come, but they will come in a form where it is a part of some other big question. But however, this section is very, very important. Learn the concepts and be sure about the concepts. I wish you all the best. Thank you.